Have you ever wondered what the correct temperature for our Earth should be? With climate proxy data stretching back millions of years, how do we decide what is normal and what is cause for concern? The answers lie in the intricate tapestry of Earth's climatic past. Consider this. The popular narrative on climate change often relies on data from the last 140 years, a mere blink in the grand timeline of our planet. Yet, the Earth has weathered climatic upheavals for billions of years, a testament to its ever-changing nature. The climate of our world has always been in flux. It's not a static entity, but a dynamic system that ebbs and flows in response to a myriad of natural factors. The belief that human activities are solely responsible for global climate shifts is a well-publicized theory, but it's essential to remember that our climate's history runs far deeper than human civilization. Our understanding of Earth's climate history is based on a wealth of data that include ice core samples and tree ring analysis. For instance, Vostok ice core data from Antarctica reveals that the continent was 1 to 3 degrees Celsius warmer periodically, with 4 maximum temperature spikes occurring over the last 400,000 years. These peaks and troughs in temperature are a reminder of the Earth's natural climatic rhythms. Moreover, sea levels have also fluctuated dramatically over time. Around 70 million years ago, at the end of the Cretaceous period, sea levels stood at 220 meters higher than today. Fast forward to just 10,000 years ago, and the oceans were approximately 120 meters lower than they are now. The climate changing is not just about temperature, carbon dioxide, and sea levels. It's also about understanding the broader natural patterns that underpin these changes. Over time, we've been able to identify patterns of intense weather variations, with cycles of warming and cooling recurring throughout history. These patterns, woven into the fabric of our planet's past, provide invaluable insights into the mechanics of our world and hint at what the future may hold. Tree ring data, collected from locations in the Northern Hemisphere, have been instrumental in reconstructing temperature sequences over the past 8,000 years. The growth patterns of trees serve as a natural archive of climate conditions, offering a glimpse into periods of warmth and cold. Similarly, radioactive carbon-14 or 14C provides insights into cosmological events and fluctuations in solar radiation. Formed in the atmosphere, 14 sea levels rise when solar activity declines, offering another piece in the puzzle of our planet's climate history. Earth's climate is a complex system influenced by a myriad of factors. It's a naturally dynamic system that's perpetually shifting, marked by cycles of warming and cooling, sea level changes, variations in solar radiation, and many more naturally occurring cycles. It's crucial to remember that these activities are but one piece of a much larger puzzle. The more we understand about our planet's climate history, the better equipped we'll be to navigate its future through our ability to adapt. Have you ever wondered how shifts in the Earth's climate have shaped the course of human history? How different would our world be if the climate remained constant over the millennia? We dive deeper into the fascinating story of changes in climate and its profound impact on civilizations. In the deep recesses of our planet, hidden within ice cores and ocean bed layers, scientists have discovered a treasure trove of climatic information. These ice cores, drilled from the deepest parts of the Earth, contain beryllium-10 isotopes, which reveal repeating cycles of climate change. From these records, we learn that our planet's climate has always been on a cyclical path, with major erratic periods in weather systems occurring long before human industrialization. Rewind to 4,000 years ago during the Minoan Bronze Age. It was a period warmer than our modern times, as was the Roman period and the medieval warm period. These warm periods led to the expansion of civilizations, allowing them to flourish. In the 1st century AD, Romans were even cultivating grapes as far north as York in England, a feat not possible today due to cooler climates. However, these periods of warmth and prosperity were not everlasting. The medieval period, for example, was a time of significant human expansion within agriculture and architecture. Experiencing over 3 centuries of temperate climate, this period enabled the population of England to rise from 1.4 million in the late 11th century to 5 million by the year 1300. 2 cold periods toward the end of the medieval era, known as the Wolf Minimum and Spora Minimum, played an intrinsic part in leading to the contraction of such expansion. Like many other notable times in human history ending in collapse. But why does this happen? Simply, civilizations flourish in warm, stable conditions and contract when prolonged cold spells return. Cold weather brings with it uncertainty and extreme changes, creating challenging conditions for survival. The history of solar activity further supports this. Periods of decreased solar activity, or solar minimums, correspond with cooler global temperatures. These include the Oort, Wolf, Spora, Maunder, and Dalton minimums, all of which had significant impacts on human activity. Take, for example, the Maunder and Dalton minimums. These periods were characterized by extreme winters, flooding, and drought, which devastated crop production worldwide. The Maunder minimum, a grand solar minimum, even saw the River Thames freeze over, enabling ice fairs and ice skating on its surface. An ever-changing climate has been a constant companion to human civilizations, shaping their rise and fall. From the warm periods of the Minoan Bronze Age, the Roman era, and the medieval period, to the cold spells of the solar minimums, the Earth's climate has always been in flux. These shifts in climate have had profound impacts on human societies, influencing their expansion and contraction. They have led to the flourishing of civilizations during warm periods and their decline during cold spells. Naturally induced climate changes are an intrinsic part of our planet's history and will continue to play a significant role in shaping our future.